There is still a common misconception or misunderstanding about the difference in concrete and cement. Cement is the material that is in a powdered form and provides the chemical reaction, bonding aggregates together through the paste produced. Concrete is the final product of aggregates, cement, admixtures, and water mixed together to form a mix. This concrete mix is poured and finished, and after the hydration and curing process, provides a solid rock-like surface. To call a sidewalk a cement sidewalk, for instance, would be similar to calling a cake a sugar treat. While the sidewalk does contain cement, it could not be a sidewalk without the other necessary ingredients, in the same way a cake could not be a cake without the flour, eggs, etc. The original 1938 batch plant was replaced with a new batch plant in 1957. This plant operated until 1996, when the current plant was built and relocated on the north end of the property. The current Erie Stayer plant has modernized the process, removing levers and replacing them with buttons and computer keyboards. This computerized process is capable of delivering high-quality concrete at a maximum rate of 150 yards per hour. On multiple occasions, Salina Concrete has supplied projects within the city of Salina in which over 1,000 yards were poured in a single day. The Erie Stayer plant is operated with a command Alcon control system. This system is a computer-controlled process using state-of-the-art technology to produce premium concrete. The system uses probes and scales weighing out materials to the pound and continually checks moisture readings, making adjustments as necessary as materials are loaded into the truck's drum. This state-of-the-art technology continuously measures material densities and moistures to ensure a good mix is delivered to customers. Salina Concrete is concerned with being good stewards of our natural resources. To this end, a state-of-the-art BFK Technologies concrete reclaimer was installed in 2011. This reclamation system allows all unused concrete to be recycled so that all aggregates are reclaimed and available for reuse. Additionally, all water is contained within the system, preventing any unwanted runoff. As the video shows, when drivers return with excess concrete, they back up to the reclaimer. When the truck backs up the ramp, a sensor registers that the truck is in position and discharges recycled water into the drum, watering down the mix. The truck will then mix the excess water into the mix and discharge the watered-down material through the reclaimer. As the materials pass through the screens, all of the sand, rock, and cement is cleaned and segregated. The pump then kicks on, flushing the concrete with water and sifting it through a grate system separating the sand and rock. These aggregates are then cleaned and available to be blended back into the existing aggregate stockpiles for future use. All the water is then retained within the system and reused to clean future loads, providing a self-contained system without any adverse effects on the environment. Salina Concrete's fleet began with 1- and 2-yard chain-operated mixers. The fleet consisted of 6 trucks by 1945 and continued to grow through the years in terms of number and capacity. Over-the-road trucks, similarly, were undersized by today's standards and required unloading by hand. Currently, Salina Concrete has a fleet of 8 mixer trucks with 10-yard drums, 2 semis, 2 boom trucks, and a flatbed to address the wide array of products for our customers' needs. Concrete block are a relatively new building material, with builders first experimenting with block production in the mid-1800s. The first U.S. patent was given to C.S. Hutchinson on March 6, 1866, for a hollow block. Block was developed and used as a result of skyrocketing costs of lumber and brick. In the early years, the hand tamping machines were taken to the job sites and the block were produced there. Materials were inexpensive, and the only cost to produce a block was the cost of the machine, which in 1906 sold for about $100 each. As a result of the large number of backyard and basement producers and no testing of their materials or quality assurance during the infancy of the industry, concrete blocks struggled to gain acceptance with masons, architects, and engineers. Through the efforts of many pioneers, as well as the formation of the National Concrete Masonry Association, the industry gradually gained acceptance through testing and quality assurances. With time, backyard and basement producers were slowly replaced by production plants with technology and automation that could mass-produce block with tight tolerances. These plants could produce thousands of high-quality units in a day, whereas the hand-operated machines were only able to produce 8 to 10 blocks per hour. Within the state of Kansas, a group of producers formed the Kansas Masonry Industries Council, or KMIC, in 1952. Salina Concrete was a charter member of this group, and in 1952 there were 27 block plants operating within the state of Kansas. These plants were scattered throughout the state, operating within close proximity to areas of high population. Plants were found in cities such as Lawrence, Garden City, Clay Center, and Junction City. In 1952, Topeka had 3 operating plants. Through years of competition and the development of technologies allowing for mass production, concrete block production facilities were consolidated throughout the state and country. Of the 27 plants operating in 1952, only 5 continue operating within the state of Kansas in 2013, one of which is Salina Concrete. Salina Concrete added concrete block to the production mix in 1938. A Stearns machine was first used in Salina and made 900 blocks per day. In 1952, a Besser 1948 B3R was installed and replaced the old Stearns machine. Salina Concrete purchased the machine through a royalty program and paid a penny per block made to Besser. Salina Concrete paid a machine operator an hourly wage with a bonus of a penny per block once the quota was achieved. With the Besser, Salina Concrete could now produce 4,000 blocks a day. Production capabilities continued to increase with the addition of a new loader and unloader system installed in 1966. This plant configuration was run until 2001, when another Besser V312 was installed and is still in operation today. The current plant can now produce 7,000 blocks in a day. Salina Concrete still produces concrete block daily in the production facility that originally was built for silo stave production in 1913. The product mix consists of load-bearing masonry units, landscaping products, which are available in virtually every color of the rainbow. Block produced in this plant can be found in homes, schools, banks, churches, and thousands of other facilities throughout the state. 2 local examples are Salina Central High School, constructed in 1952, and Salina South High School, constructed in 1971. The Salina Concrete sales and production personnel work tirelessly to provide a high-quality product which customers have affirmed to be true for decades. To understand how a block is produced, you will see here in the video, aggregates such as sand and haydite are delivered and deposited into the pit at the base of the elevator. Through the use of gravity and vibrators, these materials are moved down the pit to the mouth of the bucket elevator, which takes the aggregates 1 bucket at a time overhead and deposits them in the appointed silo. Cement is delivered and stored in the same way as is done with the ready-mix department through pneumatic trailers and blown into overhead storage with the Cyclonair system. Once all the materials are in place, the computerized system will then batch appropriate volumes of aggregate, water, cement, admixtures, and colors into the mixer. As is the case with the ready-mix batching, this is a computer-controlled system ensuring the highest quality control during production. After the mixer has adequately mixed the materials together, the zero slump concrete is dumped into a bucket, which is then elevated to the top of the block machine and dumped into the hopper. The machine then, through the use of cams and extreme vibration, shakes the material into the feed box, which is in turn compacted into the mold box, providing the structure for the concrete shape being produced. The machine will cycle, producing 3 8x8x16 units at the rate of 5 to 6 cycles per minute, or 15 to 18 blocks are produced per minute during a typical production day. The units that come forth are essentially sand castles, in that they are very fragile and can be easily broken when minimal hand pressure is applied. These units are then put into kilns for curing. The curing process uses heat and steam, with temperatures reaching 160 degrees for extended periods of time. This process accelerates the curing process, and within 24 hours, the units that were sandcastles are now rock-hard masonry units. These blocks, when tested at 28 days, typically have PSI strengths exceeding 3,000 PSI. Technology has added greatly to the performance and aesthetics of concrete block. Concrete block, which were developed at the turn of the century, were only available in a gray color and a smooth surface. These units were structurally sound, but were unable to prevent moisture from penetrating them without a good painted surface. Today, concrete block, while still structurally sound, are available in almost every color of the rainbow and have multiple textures such as rock-faced or scored appearances. Additionally, through the use of admixtures, these block can become a watertight unit, preventing water from penetrating the surface of the unit. The first addition to the Salina concrete product mix following silo staves was precast products. After the formation of the company in 1913, the production of decorative cast stone was added to the product mix in 1918. Precast was a natural addition to the product mix since Salina Concrete had a skilled workforce adept at working with low slump concrete products needed for silo stave production. The cast stone for Memorial Hall was produced in the Salina Concrete Yard and delivered and set in place with teams of horses. As a tribute to the quality of this material and masonry in general, this building still stands and is used by the city of Salina. Another project of note in which the decorative architectural precast was used and is still available for viewing is Asbury Hospital. In addition to architectural units, Salina Concrete also fabricated well casings and other construction materials. Salina Concrete still employs a full-time crew which operates within a new building built solely for precast production, which was constructed in 1995. Within this building, the Salina Concrete crew produces high-quality items such as wet cast retaining wall units, septic tanks, feed bunks, parking bumpers, barrier blocks, and memorial markers. The precast department was originally located in the same plant area as the block department, using the floor space to place and produce forms. As both departments grew, this no longer became an option to do both effectively. It was for this reason that in 1995, when the new batch plant was built, a new dedicated state-of-the-art precast facility was built as well. This building provides Salina Concrete staff the use of a gantry crane, consistent heat, and a significant level floor space for production.